So in this video we'll be discussing like how we can design Half-Subtractor. So again, I would like to go from example like where exactly Half-Subtractor is used, right? Like half adder, even this Half-Subtractor is also used to subtract single bit number, like for example 0 0, right? If we subtract this number and like 0 and 1 and 1 and 0, right? Okay, so in order to subtract 0 from 0, we don't need borrow. So I mean, so our borrow would be 0 and our difference would be 0. Okay, so similarly, if we want to subtract 1 from 1, sorry, 0 1 from 0, then now we need borrow. Okay, so we need borrow of 1. So okay, so this would be like 1 0. Like if we subtract 1 from 1 0, then our difference will be 1. Okay, so this is difference, even this is also difference. Okay, now if we want to subtract 0 from 1, now again borrow would be 0. We don't need borrow, right? So then 1 minus 0 would be 1. So this is difference. Okay, so this is difference and this is borrow. These are borrows. Okay, so using this again same method, now we can draw the truth table for Half-Subtractor. Okay, let's draw the truth table. Okay, so first again I'll just start making the table. So again here, there would be like two boxes, like one for inputs and another for outputs. And again we have like two variable a and b, and again two variable difference and borrow. Okay, so again for two variable there are like the combination is like there are four combinations: 0 0 0 1 1 0 and 1 1. Okay, so now if we subtract 0 minus 0, our difference would be 0 and borrow would be 0. Okay, so now if we want to subtract 1 from 0, then now we need borrow, right? Because we cannot subtract 1 from 0, so now we need borrow 1. So now this would be like, if we take 1 borrow over here, okay, I'll just change the color, okay, just for easy purpose. Okay, so now if we take borrow 1, okay, then now 10 minus 1 would be, I mean it's not a 10, but it's 1 0. 1 0 minus 1 would be 1, and our borrow is again 1. Okay, so now if we subtract 1 minus 0, our difference would be 1 and borrow would be 0. So now again if we subtract 1 from 1, then difference would be 0 and no borrow is needed, right? So it would be 0. Okay, so this is the truth table for Half-Subtractor. Now again, now in order to get the Boolean functions, now we have to use K-map. Okay, so okay, now we will find the Boolean function for half adder, okay, using K-map. So again, as I have mentioned in half adder, like again there are like two output, difference and borrow, right? So now again we have to make two separate K-map for each output. So now let's take this as an output right now. Okay, so now for difference we'll have one K-map, right? So now we'll make a template. Okay, so now here we'll write a and b, and there are like two possible values, 0 and 1, 0 and 1. Okay, and we'll substitute these values. Okay, we'll substitute these values: 0 1 1 0, 0 1 1 0. So as I mentioned before, right, so we have to encircle this 1. This is the only possible way of encircling 1. So now our difference would be, so if we take this one, okay, for this, a is 0, so that is a bar, I mean a dash, and if look at b, then it's b, just b. Okay, so plus. Now if we look at this one, okay, so a is 1, okay, and b is 0, so that would be b dash. Okay, so again this is like a function for XOR, right? So that would be A XOR B. Okay, so now we'll again make a separate K map for borrow. Okay, borrow K map. Yeah, so okay, we'll make a table. Okay, so here would be A and B, 0 and 1, 0 and 1. Okay, so now for borrow we'll be taking this output, right? So 0 1 0 0, that would be 0 1 0 0, right? 0 1 0 0. Yeah, so now this is the only possible way of encircling 1, right? So if we look at this one, then our A is 0, so that would be like borrow would be A dash, okay, and B would be 1, so that is B, so that is A not B. Okay, so again, just to summarize, we have got two boolean function for difference and borrow. For difference we have got like A XOR B, and for borrow we have got A not B. Okay, but it's a I mean again AND gate between A not and B. Okay, now if we make a logic circuits for half-subtractor, we have to use the same boolean function. Okay, so now we have two input, A and B. Okay, so let's make difference, that is XOR B, right? If we do this, that would be difference. Okay, so now for borrow, there is A naught. Okay, this is A naught, and there is AND gate between A naught and B. Okay, so there is AND gate A naught, and this would be B. Okay, so this is borrow. So this is the logic circuit. Okay, so we'll be using the same logic circuit to make, write VHDL code for half-subtractor. Okay, so now let's go for, okay, so now next step is like VHDL code, right? We'll write VHDL code. Okay, thank you. Okay, so let's write a VHDL code for half-subtractor. Again, let's make a new project, half-subtractor. Okay, so as I've already explained, like we don't have to do anything, right? So we just, this has to be like VHDL. Just be careful of that, otherwise we'll just skip everything. Okay, so now we'll just create a new source. We'll do again with VHDL module. Okay, I'll just name it as half-subtractor. Okay, so nothing to do. Okay, so again, okay, so I'll just remove this comment just to make the code more clear. As I've already mentioned, you know, like there are like 3 sections, one each, like library declaration, and there is another is entity declaration. Okay, and another is architecture declaration. Okay, okay, so now we have to define what are inputs and output, right? So I'll just do again, I'll just keep A and B as input with the standard logic type, and again difference and borrow as our output. Okay, now standard logic type. Okay, so now, you know, we have to use the same boolean function which we had got from the truth table using K-map, right? So using same logic circuits, I mean logic boolean function, now we can design the architecture for half-subtractor, so that it's like difference would be A, like you can just go back and look for the boolean function for half-subtractor. Okay, so it's A XOR B, and borrow it not A and B. Okay, A not and B. Okay, so that's all. So now let's test if there is any error on our code. So for that we have to keep it on implementation, and then so we have to synthesize the code, right? Okay, so there is no any error on our code, so because it's showing completed successfully, right? So now we have to do the simulation. So for that again we'll go and add a test bench, and I'll just name it as Half-Subtractor test. Okay, so nothing, wouldn't need to worry about anything. So like first of all, let's remove comment all the clock signal, because we don't need this. So for commenting you just have to press alt plus C. Okay, again alt plus C, and this will comment this both alt plus C. Okay, so now we have to pass all the values for our input variable, that is A and B, like 0 0, right, 0, and for B also we'll pass it 0, and we'll wait for 100 nanosecond. Okay, and just to pass all the possible combination we have to let's copy it like 4 times. Okay, so 0 0 0 1, okay, 1 0, and 1 1. Okay, so that's all. So now for running this simulation we have to like select this simulation. Okay, okay, I think there is some error. Let's just go and check. Wait for 100 nanosecond. Okay, oh okay, I just forgot a semicolon. Okay, so like we have to select the simulation, and then we have to press this, then we'll get this IC simulator, and then we'll just press that simulate behavior model. Okay, oh I don't know, some error is there. Okay, what error is there? I'm just confused. Okay, oh sorry, I just forgot. No, I don't have to do anything over there. Oh, I forgot over here. Okay, so semicolon. Okay, let's check. Okay, even here semicolon is missing. Okay, my bad. Like, be careful of this thing. Okay, so now we'll just press this. Okay, it's already in simulation. Okay, so this is the output. Just we have to adjust the view. Just to adjust we have to press this zoom, okay, to full view. Okay, so now let's check, like, you know, when our A and B are both 0, both our difference and borrow would be 0, right? But if we have like A is 0 and B is 1, like we have to subtract 1 from 0, so in that case we need borrow 1, right? So once we take the borrow, A would be like 1 0, like, and if we subtract 1 from 1 0, then our difference would be 1, right? So now when A is 1 and B is 0, then difference between 1 and 0 is like 1, but in that case we don't need any borrow. And finally when A and B both are 1, our difference is 0, and also in this situation we don't need borrow. Okay, so this is all about Half-Subtractor. Okay, thank you very much.